Due to evaporation, tiny water droplets are tightly packed together in the atmosphere. They defy gravity because of their light mass in relation to their surface area, which enables them to be carried by air currents. Intermolecular forces bring them together, causing several small droplets to combine into larger raindrops. The combined drops finally give in to gravity and fall to the earth as rain, because their mass increases more quickly than their surface area as they get bigger. Intermolecular forces that hold molecules of the same substance together are called cohesive forces. The phenomenon itself is called cohesion. When water is poured into a glass, a noticeable effect can be observed at the boundary between the water and the glass at the water surface. The water molecules have climbed up the glass. This phenomenon occurs because water molecules are not only attracted to other water molecules, but also to glass molecules. The forces between water molecules and glass molecules that cause this attraction are known as adhesive forces. The overall phenomenon is referred to as adhesion. Adhesive forces are the interactions between molecules of different substances. The appearance of the liquid surface in a glass doesn't always have to resemble what is shown in the image. When mercury is poured into the glass, the surface of the mercury at the points of contact with the glass curves in the opposite direction. What factors influence the curvature of a liquid's surface? It is the interplay between cohesive and adhesive forces. In the case of water in glass, the adhesive forces between water and glass are stronger than the cohesive forces between water molecules. Therefore, in an attempt to establish a more direct contact with glass molecules, water molecules begin to climb up the glass. Climbing up the walls of the glass, water molecules increase the free surface area of the liquid, which is opposed by surface tension. The balance between these two tendencies, the force of adhesion on one side and the force of surface tension on the other, stops further climbing of water up the glass. In the case of mercury in a glass, the scenario is quite different. The cohesion among mercury molecules surpasses the adhesion between mercury and glass. The mercury molecules, inclined to seek more direct contact with each other, move away from the glass, causing the surface touching the glass to curve in the opposite direction. The curvature is primarily affected by gravity, which seeks to distribute the liquid, and by surface tension, which strives to reduce the liquid's free surface area. The curvature of the liquid at the point of contact with the container is known as the meniscus and can exhibit a concave nature as seen with water in glass, or a convex nature as observed with mercury in glass. The iconic image of wine in a glass shows droplets of liquid trickling down the glass into the wine, known as wine tears. What leads to this romanticized portrayal of wine in a glass? Wine is a blend of water and alcohol, along with various aromatic particles, sugars, and more. Water and alcohol possess distinct properties. The cohesive forces among water molecules are notably stronger than those among alcohol molecules. Additionally, the adhesive forces towards the glass are stronger than cohesive forces for both water and alcohol. In wine, the cohesive forces are weaker than those in water, but stronger than those in alcohol. As adhesive forces surpass cohesive forces, the wine starts to climb the glass walls. This causes a thin layer of alcohol and water build up on the glass walls above the wine's surface. However, alcohol is a more volatile liquid compared to water. Alcohol molecules from the thin wine layer on the glass walls evaporate more readily than water molecules, leading to a decrease in alcohol concentration in that liquid layer, allowing water molecules to take over. The cohesive forces among the liquid molecules on the glass walls now exceed the average cohesive forces among the wine molecules in the glass. These stronger cohesive forces on the glass walls attract new molecules from wine in the glass, causing the liquid to continue ascending the glass walls. But why doesn't the surface tension counteract the adhesive forces lifting the liquid on the glass walls? It does. However, since the cohesive forces in wine are lower due to presence of alcohol, the surface tension value is also reduced, enabling the liquid on the glass walls to climb significantly higher. The liquid on the glass walls is nearly pure water, which, due to high cohesion, forms droplets that cascade back into the glass under the pull of gravity, thus creating wine tears.